Hello, I'm Mark Colley and I'm happy to present our paper, Increasing Pedestrian Safety Using External Communication of Autonomous Vehicles for Signalizing Hazards. Pedestrian safety is still an ongoing challenge. For instance, in 2018, over 6,000 pedestrians died in traffic crashes in the USA, and 458 died in Germany. With the introduction of automated vehicles, the possibility and potential need for external communication is currently being evaluated. Some examples are presented here. Some research already proposed to use display or projections of standing automated vehicles to communicate warnings to pedestrians. The envisioned scenario can be seen in the two figures presented here. On the left side, an example from the real world is shown, with numerous vehicles blocking the side for drivers and pedestrians. On the right side, you can see the scenario we designed and implemented. The research question guiding the experiment was, how are behavior as well as trust, situation awareness, the crossing decision, and preference of pedestrians impacted by cognitive load, visualization of approaching direction, and location of communication. This resulted in a 2x2x2 within subjects design. The cognitive load was induced by the NBAC task. The visualization and location are shown on the next slide. We recruited 20 mostly younger participants and measured objective measurements such as the NBAC task performance, location, and duration. We also measured subjective measurements such as mental workload, situation awareness, and trust. This figure shows the 4 visualizations. Figure 1 shows the warning on the vehicle, Figure 2 shows the warning and additionally the direction information of approaching vehicles. Figures 3 and 4 show the concept for the infrastructure. We included the infrastructure as the smart road concept was already proposed as well. While other researchers also included the smartphone and showed potential interfaces, we tried to design a scenario where the pedestrian is not distracted by the smartphone and, therefore, has no access to it. In the background, the canvas for the NBAC task is shown. Due to time constraints, we go straight into the discussion. We found that the participants needed longer between trigger 2 and 3 without induced cognitive load for the areas. Therefore, we state that participants were aware of this communication, as confirmed by them. The most important finding regarding crossing time is that participants waited almost significantly longer in between the parked vehicles, that's between trigger 3 and 4 in the shown figure, without directional information presented. Therefore, we conclude that showing such warnings warns pedestrians of potential dangers and is therefore beneficial to traffic safety. Regarding the purpose of the communication, some participants misinterpreted the information as instructions and even demanded clearer instructions. Therefore, while most participants preferred systems with direction information of the approaching vehicles, we believe that this information should not be displayed. While time to cross is negatively impacted, safety is most likely to be heightened by this. While some participants mentioned that the communication should have been present on the opposite side, we explicitly used the near side to evaluate if the communication would be also useful there, which we could show. While the usefulness increases with a higher number of automated vehicles, we believe that even with a small number of automated vehicles presenting these cues, such a warning mechanism could increase safety. When automated vehicles do not visualize this information, no deficit occurs. Therefore, we argue that this concept should be considered for future automated vehicles. Thank you for your attention, and I'm happy to take questions.